Hi again, Matt Smith, Senior Applications Engineer at Schunk USA. We're doing this series to demystify the magnetic when it comes to gripping and handling with magnetic gripping systems. Today we're going to talk about a misconception that bigger magnets perform better than smaller magnets. In other words, bigger is better, right? Let's dive into that subject and we'll see that that's not always the case. Let's go. Magnetic grippers are constructed with a north pole and a south pole, which you can see here in this bipole magnet. Magnetic flux flows between the north and south, and when the metal part is placed on the magnet, the part becomes a part of the magnetic circuit. With magnetic gripping, the metal thickness determines the magnet used. The thickness of the metal is the first thing to know when choosing a magnet gripper. Here's why. Flux is invisible, but if you could see it, it would look like this. Notice the flux goes from north to south directly and is very concentrated. This is important because the size of the pole determines how deep the flux goes into the part. The bigger the poles, the deeper the flux goes into the part. Now let's look at how this relates to the workpiece. This is an image of a magnet holding a part. Notice that the metal thickness and the flux depth are the same, meaning the magnet is clamping with full strength. Since we're experimenting, let's see if bigger is better. Let's take a look at how a bigger magnet will work on this plate. This image is of the same steel plate with a bigger magnet. Notice the flux radiates outside the part. This reduces the clamping force available from the magnet, and the magnet could pick up two parts instead of one, known as a double pick. Can you now see that bigger is not always better? So if bigger isn't always better, how are large, thin steel sheets handled with magnets? Remember when I said the size of the magnet pole determines the depth of flux? Is it possible to handle thin metal and still have good clamping force? Yes, it is possible with this type of magnet called a monopole magnet. The center strip is the north pole and the body is the south pole, reducing the size of the poles and creating a short flux band. We have several types of monopole magnets, which are very strong for their size. This magnet shows the correct magnet for this thin part, which has smaller poles. Because this magnet can now work at full strength, it proves that bigger isn't always better. In cases like this, 2 or 3 smaller magnets will outperform one large magnet. Just to prove that bigger isn't always better one more time, see what happens when we use a big magnet on this same thin sheet? There is barely any metal for the flux to hold on to, and much of the flux is wasted. Not to mention that this magnet could now double, triple, or quadruple pick parts, which is really bad. As parts get larger and heavier, the need for larger magnets with more capacity is needed. Shown here are 2 other configurations that have 4 poles in a line and 4 poles in a square. These are the most powerful magnets, which have a payload capacity of hundreds of kilograms. Like before, flux is invisible, but if you could see it, this is what the pattern would look like. If you have an application handling steel parts, give us a call. Thank you for watching.